where we were at yesterday. Alright, so it looks like yesterday we just did 6 and 12. Was that right? I think. Because I wanted to look at a couple more problems. And I gave y'all, let's see, 7, 23, and 25. Did y'all get through those, or did you have any questions about them? Okay. Alright, well, if you think of your question, you can ask it at some point. If not, we'll just try to look at some different problems. Alright, let's look at 14. So you have to have your book, because obviously they have like pictures and stuff we're looking at. A National Vital Statistics report indicated that nearly 300,000 Black Americans died in 2003 compared with just over 2 million white Americans. Here are histograms displaying the distributions of their ages at death. Describe the overall shape of these distributions. Okay, both skewed left. How do these distributions differ? Yeah, you could say both of them are unimodal also on that. What appears to be the difference in the two? Yeah. And what do you also notice, like, comparing ages, like, 25 through 84 in general? Yeah. So there's more from 25 to 74, more Black Americans. Died versus 85 plus, more white Americans died. Okay, in the 75 to 84, yes, technically it is lower. I guess you could really say 75 plus rather than 85 plus there, because there's definitely more in that category for the white Americans. And then the last question, look at the barred definitions. Where do these plots violate the rules for statistical graphs? What is wrong with those two graphs? What do you mean? Comparatively, that doesn't necessarily matter, but there is something that has to deal with numbers that is wrong. Yeah, there's no label on the left side, so we don't have a clue what the left side is talking about. It's just got numbers that basically have no meaning because they're not labeled with units. What about, what do you notice about the spans of years? Yeah, so it's like 4 years versus 9 years versus like 85 plus. I mean, that could be like a 20-year span. I mean, who knows? Huh? The bottom, so like the bottom of the graph, how you have the number of years and stuff. What? They're not. They are between the two graphs, but each graph individually has like 0 to 4. So like you said, that only spans like 4 years, whereas then the rest of them span like 9 to 10 years ish, and then the last one is over. I mean, it's who knows how many years. I mean, you can have somebody live to be 110. Happens a little less frequently now, but I mean, you could have somebody live that long. So that could be covering a span of like 25 years. So I would say something about the spacing of years or the span of years is different or is not constant. Okay, we'd want them to all be constant when we're looking at it. Okay, example, 0 to 4 years, 5 to 14 years, and then 85 plus. Okay, that's so many different possible ranges there that you have. They should all be the same. They should be like 0 to 10, or they should be like, if they want to go with smaller increments like 0 to 5, 5 to, or like 0 to 4, 5 to 10, or whatever. You know what I mean? Like, pick something and stick with it. So anyways, that's what's wrong with that one. Is there anything else? Does everything else look good on that graph? Okay, they have the label at the top. The bottom does have labels. Technically speaking, they could have just written at the bottom. They could have just written years once and just said like year, like span in years or something like that to label the whole thing instead of writing years every single time. But that's what they have isn't necessarily bad because at least it's labeled. Let's see, 16. Here are box plots of weekly gas prices at a service station in the Midwest part of the United States, and prices are in dollars per gallon. Compare the distribution prices over the 3 years. So what do you notice? Yep, each year it's going up. You could say the average price goes up, or average price increases. What else could you say about it? Yeah, the dot is like probably like a I'm trying to think of how let me see if they specify how they're labeling these. Because we've had some dots before and I just assumed they were labeling them as outliers. I want to make sure we know how they're specifying them. Yeah, so it looks like they're saying that they're using two definitions for outliers. They're using just an outlier and then they're using a far outlier. So I assume that the dots are probably specifying outliers, and then the starred ones are probably the far outliers that like really affect it. But I'd have to verify that, and they're not super specific here. Yeah, so okay, so on page 81 it addresses that. It says, we add outliers by displaying any data values beyond the fences with special symbols, so like the dots, and then it says we often use different symbols for far outliers, which are data values farther than 3 IQRs away from the quartiles. So far as I'm concerned, if you're graphing one for me, you don't need to like label them differently. Just label all of them as stars. Okay, but just know that in the book, the stars do technically mean that it's farther away than three IQRs away. Okay. So like how we do, like when we find the outlier, we use like the 1.5 IQR. They're using 1.5 for anything that's circles. Stars are 3 times the IQR instead. So the average price increased each year. We had a lot of outliers in 2002. You say 4 outliers in 2002. What do you notice about them, like about the skew for each year? Yeah, 2002 is skewed left. Okay, 2003 and 2004 were skewed right. Trying to make sure we've covered everything. We have 4, we should say probably low outliers in 2002, and then we can say 1 high outlier in 2004, just to address that as well. Is there anything else we notice about this? I think that's pretty good. Yeah, so we've still addressed kind of our shape, center, and spread dealing with this, okay, because we talked about, the outliers, we've talked about the average price, we've talked, not specifically, but we've talked about how it increased each year, and then we talked about the skew, so I feel like that's probably, if you've answered those things, that's pretty good. And if it wasn't skewed, if they were about the same, then we could say, they're unimodal and symmetric, things like that. Part B, in which year were the prices least stable? Yeah. So you've got prices down as low as $1.50 and as high as $2. So just that range is much greater in 2002. So I would just say something about 2004. Range was much wider. In regards to price. Something like that is sufficient. It also, another thing here that the book points out is, in the answer, is that it also has the biggest IQR, which I think you kind of said, one of you kind of said. Biggest IQR also is occurring there. 22. A survey of 1,021 school-age children was conducted by randomly selecting children from several large urban elementary schools. 2 of the questions concerned eye color and hair color. In the survey, the following codes were used. So it's got like 1 for blonde and 1 for blue, 2 for brown, 2 for green, blah, 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 so on and so forth. You can see that. But then on the next page, it continues. The statistics students analyzing the data were asked to study the relationship between eye and hair color. They produced this plot. Okay, so you can see that plot there. Is their graph appropriate? If so, summarize their findings. If not, explain why. Yes, they're finding a relationship between them. So is that an appropriate graph representation? Huh? One is blonde and blue eyes. Do we know how many people had blonde hair? Do we know how many people had blue eyes? No, it's not. Yeah, you can't gather any information from it. And what kind of variables are hair color and eye color? Categorical. So can we put numbers to those? No. So you say no, both categorical variables. Okay, because based on that, I mean, you can't even decide how many people had blonde hair or how many people had brown eyes or whatever just by looking at that graph. So that would just be very hard to understand and interpret anything from it. Let's see, what else? I'm trying to remember, did we do one like 24 the other day? Because I know I gave you 20. Okay. Because we did 12, but it's not necessarily. Let's look at 24, and then I'll probably give you guys a couple more to work on. You did 23 for homework last night. How'd y'all feel about that one? You did it wrong? Okay. Alright. Let's do 24 then, just to make sure we're good with that, and then I'll probably add on a few. How'd y'all do with 25 also? Everybody okay with 25? Okay. Alright, so 24, here are the summary statistics for the size in acres of Finger Lakes Vineyards. So it's got the total count, mean, standard deviation, median, IQR, min, Q1, Q3, and max. Would you describe this distribution as symmetric or skewed, and explain why? Looking at the mean and the median, what do you think is true? It's definitely skewed. Is it skewed left or right? What was true if because in this case we had mean greater than median? I was going to say, I think you were right the first time. Because the bigger values would be on the right, meaning the tail's on the left. So it would be skewed left. Okay, which is a good way to think about it. You may not necessarily remember, like right off the top of your head, oh, mean greater than median, it means this. However, if you think about like your histogram, think about, okay, well, where would the tail have to be? If my mean is that much bigger than my median, that means I have to have a lot more data on the right side, meaning that the tail would be on the left, so it would be skewed left. To determine, are you determining outliers? I mean, you could, I guess. You could do it that way, possibly. I mean, possibly, but you mainly want to look at the mean and the median to determine that. Because remember, we talked about if the mean was greater than the median, then it means this. If the median was greater than the mean, it means this. And then if they were equal, it means this. I think we wrote that down last chapter. Wait a minute. No. You were right when you switched it to right. Hold on, let me find those. Just to refresh, because I mix them up all the time. Yeah. Let me verify that that's what we had in our thing. I think that was in chapter 4. Where did we write that down? I'm trying to remember. Oh, we wrote it down on the worksheet, I think. That's right. Okay. Yeah, so from last chapter we talked about, I obviously forgot, skewed right means the mean is greater than the median. Skewed left, mean is less than the median, and symmetrical, they're approximately the same. Okay, and that's because the big numbers affect the mean. It doesn't necessarily mean that there's more of them there. But the median isn't really going to be affected by the big numbers or the small numbers. It does kind of look like 6 foot. Leave that there for a second. Let y'all write that down again. Alright, so then, okay, so that one was skewed right. Maybe now I'll remember that. You probably could figure it out, or you could draw a box plot and then look at it and decide. So if we had left that as skewed left, when we go to draw the box plot, we would have realized, or I would have realized that I was wrong. Alright, so I would say skewed right and then say something about mean is greater than the median for the reasoning. Let's see. Then B, are there any outliers? So how do we check that? Which is what? So we have 18.5 minus 1.5 times, what did you say, 36.5? And then Q3 is 55 plus 1.5 times 36.5. So what are our fences then? What is Q3? What'd you get? Okay. I thought you said 1.9, and I was like, there's no way it's 19. Alright, so then based on that, do we have any outliers? Are you sure? What is our max? Okay, so yes, we have an outlier. There's at least one outlier. Because 250 is max, which is outside of the fences. And then the next one says to create a box plot for these data. Okay, so I go down as low as 6, so I'm just going to start at 0. And I guess I'll go in increments of, well, I'm going to go in increments of 10, and then I'm just going to jump to the over to the 250 because I'm not going to, we have a lot going on in this small area here, so I'm just going to do like a broken line kind of thing and say that we're jumping to 250 from there. So then drawing the plot, we have a min of 6. We have a Q1 of 18.5. Our median is 33.5. Our Q3 is 55. And then our max is at 250. Yeah, it's definitely skewed right. If we knew the point prior to this, if we had like actual list of data, we would probably stop at the top of our fence here and then list this as an outlier. Okay, so the other option that you have for this, try to do this in a different color. You could label an outlier here at 250. You could go out to, we said our max was 109, so we could cut it off here at 109. Okay, going in if you wanted to, and that would be okay because that would be the highest. And then you could have your outlier shown out here. But that's up to you. If you were to draw it this way, I would accept it. Or if you were to draw it at the fence and then draw your outlier, I would also be okay with that. So the last thing, write a few sentences about the sizes of the vineyards. Yeah, so they go down as low as 6, as high as 250, so 6 to 250 acres. Maybe something about Most are around 33 acres or around 34 acres. You could talk about the IQR, like the middle 50% being 36.5 acres. Or, well, they're not 36 acres isn't necessarily true. They're sized between 18.5 and 55 acres. Okay, stuff like that. You might could, say something else about the mean or the median, whatever, but overall that's pretty good. Any questions about those? All right, so let's see. Adding on, well, hold on, let me see first. Okay, with something, we're not going to actually do it, but just look at 32 for a second. I'm going to give you one like it to do, I think, but I might have you guys do that one, or I might give you an odd one, I don't know yet. Anyways, okay, with this one, it's looking at the health risks of smoking, the study examining the health risks of smoking, measured the cholesterol levels of the people who had smoked for at least 25 years and people of similar ages who had smoked for no more than 5 years, and then stopped. Create an appropriate graphical display for both groups and write a brief report comparing their cholesterol levels. Here are the data. If you were going to draw a graphical display for that, what do you think would be a good option? Huh? A box plot would work. Okay, you possibly could do still your histogram, but given this section, I'd say probably a box plot. Do you guys know how you would be able to draw your box plot based on that? Yep, you have two different ones. You could do parallel box plots so that they're on the same thing. I'm pretty sure, I don't know that your calculator can do two of them, but your calculator can draw a box plot for you. With your stat plot, you have the option of the box plot option. There is the one that's got the two things in it. Okay, I think I still have stuff in my X list, so let's see if it'll do it. Oh, hold on. I have something in my Y equals. I need to go get it out. Clear. Oh, my plot's off, that's why. I turn it on, and that would help. There we go. The issue is, yes, it draws it for you, but no, it does not label it for you. So you would still have to draw your labels and stuff, unless I just told you, draw me your box plot from your calculator or something like that, approximately what it looks like. But you would need to find your 5-number summary, determine your IQR, stuff like that. Then you would need to check for outliers, okay, because you need to draw those in if there are any, and then go from there. So I think I am going to have you guys do that one, number 32. So I don't normally give you an even one, but I'm going to give you that one because I don't really like the other ones that are there. There's still like 15 minutes left, so you might get through it. Hold on. So I know 32 is going to be added on. 26. I know some of these are even, but we're kind of out of odd ones that are good. and 19. Okay, so those three. So 26 already gives you your 5-number summary, so you'll just use that to build your box plot, and then to basically discuss the shape, center, and spread. And then, and you're already doing parallel box plots for 26. You'll also do parallel box plots for 32. I would recommend you list out your 5-number summary, find your outliers using the thing for fences, stuff like that, and go from there.